Humans have existed for innumerable generations, surveying the vast expanse of the cosmos, captivated by the wonder of the night sky and the numerous unanswered mysteries of the universe. In the 20th century, researchers introduced the Big Bang model that sought to clarify the source, expansion, and development of the universe. However, despite its widespread support, this theory still fails to address some of the most fundamental inquiries encompassing the universe. Recently, groundbreaking discoveries have revealed even more intricate layers to these cosmic enigmas. For example, in 2023, NASA's James Webb Space Telescope made an astonishing discovery. It observed celestial objects that appeared older than the universe itself. This unexpected observation has left scientists stunned, initiating confused discussions regarding whether stars can truly exist for a period longer than the currently accepted age of the universe. Such a paradox challenges our existing scientific frameworks. Is this possible? Could this inconsistency suggest the necessity for a completely new cosmological model? These and many other inquiries will be discussed in this video. To stay updated on the most recent astronomical breakthroughs, make sure to subscribe, like the video, and enable the notification bell. About 200 light-years away from our planet, in the Ascenley constellation, lies a star designated HD 114283. The star stands out due to its exceptional speed, traveling at 44.83 kilometers per second, which offers critical clues about its chaotic history. About 1 billion years ago, when the Milky Way was still in its early stages, it collided with a smaller companion galaxy. That galaxy is believed to be where this particular star was born. However, the most striking quality of HD 114283 is not its velocity, but its age. This star is one of the oldest stellar bodies ever recorded, earning the moniker Methuselah, a nod to the biblical figure believed to have lived for 969 years. Early age estimates placed it at an astonishing 16 billion years old. More precise calculations now estimate its age at 14.46 billion years, with a margin of uncertainty of about 800 million years. This variation is significant. It presents a conundrum, especially when compared to the current estimation of the universe's age, about 13.8 billion years, based on measurements of the cosmic microwave background radiation. As a result, an important question arises: what exactly is this star, and how could such a massive stellar body be older than the universe itself? Such a concept defies our present scientific knowledge. Consequently, scientists have started re-evaluating the precision tools and techniques used to determine the ages of stars and the universe. To comprehend the magnitude of this issue, it's important to understand the challenges involved in estimating the ages of stars. Suns like ours retain relatively steady dimensions and temperatures over thousands of years, making it particularly difficult for astronomers to pinpoint their ages with accuracy. One method used involves studying changes in a star's brightness and color, then comparing these findings to theoretical models of stellar life cycles. A crucial metric for determining a star's age is its spin rate. Just like a rotating object slows down over time due to resistance, stars gradually decrease their speed of rotation. By measuring the spin of stars at various stages of life, researchers have developed mathematical strategies to approximate their ages, a method known as gyrochronology. Using this method, Methuselah has been identified as possibly the oldest known star. Instead of dwelling on the possibility that it may be over 2 billion years older than the universe around us, we might instead ask, is it possible that the universe is older than previously thought? Encompassing 13.8 billion years of time is difficult to grasp. Even if the universe's timeline were streamlined into a single year, following the Big Bang, Earth would not appear until the final moments of December 31st, and human civilization would exist for only a few brief moments. Scientists determine the age of the universe by analyzing light emitted by distant stars that emerged hundreds of millions of years after the Big Bang. As the universe continues to expand, it results in a phenomenon called redshift. By studying both how far away objects are and how rapidly they are receding, researchers have concluded that the universe is roughly 13.8 billion years old. However, recent research from the University of Ottawa suggests a much earlier universe, perhaps around 26.7 billion years. Dr. Reindeer Gupta, a university physicist, proposed a theory that integrates Swiss astronomer Fritz Zwicky's concept from 1929 with modern physics advancements. His hypothesis presupposes that protons lose energy over long stretches of time and distance, a challenge to the traditional understanding of redshift. Gupta suggests that redshift could be understood as a combination effect, not limited solely to the expansion of the universe. This revised interpretation could result in a significantly older estimate for the universe and might offer solutions to enduring mysteries, especially those raised by NASA's recent observations. The foundation of Gupta's framework is the tired light hypothesis and the notion of altering interaction constants, first introduced by theoretical physicist Paul Dirac. This concept suggests that certain fundamental interactions in space and time may have evolved over time. It's crucial to acknowledge that our perception of the universe's age has significantly changed. In the 1920s, Edwin Hubble proposed that the universe was only around 2 billion years old. Later discoveries significantly increased that number, eventually settling on the current consensus of 13.8 billion years. Whether we interpret human history as lasting 10 seconds or 5 seconds in the grand cosmic timeline, one fact remains certain: the universe is extremely ancient. Its ongoing growth continues to challenge our past assumptions regarding its age. Currently, data about our own Milky Way galaxy is raising new questions. It suggests that stars on the galaxy's outskirts move at significantly slower speeds than those in other galaxies. A few possible theories have emerged. One is the possibility that our galaxy contains a much smaller amount of dark matter, an unseen form of matter thought to represent the vast majority of space's gravitational pull. On the other hand, there may be fundamental flaws in our understanding of dark matter and its distribution throughout the universe. This uncertainty is supported by information gathered from the European Space Agency's Gaia mission, which has charted the locations of nearly 2 billion stars within the Milky Way. These outcomes have led researchers to re-examine their models of stellar behavior, especially in the galaxy's outer regions. The speed of a star's orbit is a critical factor in calculating the total mass of a galaxy, as gravitational pull is directly related to mass. A recent study based on Gaia's data estimates that the Milky Way's mass, including gas and stars, is approximately 200 trillion times the Sun's mass. This is 5 times lower than earlier projections. Such a decrease may indicate a lower amount of observable material in the galaxy, possibly pointing to a reduced presence of dark matter. However, determining a galaxy's mass is incredibly complex. There may be inconsistencies in either the satellite data or the analysis methods used. As new information becomes available, as we continue to explore the cosmos with increasingly sophisticated tools, the boundaries of what we thought we knew are constantly being tested. Observations that once seemed improbable are now demanding entirely new frameworks of understanding. The universe, far from being a static or fully comprehensible entity, appears more dynamic, mysterious, and ancient than ever before. One of the most profound implications of these revelations is the potential need to revisit the foundational laws of physics. If stars can exist that seem older than the universe itself, and if redshift is influenced by more than just cosmic expansion, then the assumptions embedded in our current models may need revision. Theories once considered fringe, such as the tired light hypothesis or variable fundamental constants, are gaining renewed interest in light of recent data. Meanwhile, the study of dark matter remains one of the most enigmatic areas of modern astrophysics. Despite its proposed dominance in shaping galaxies and influencing cosmic structure, it remains undetected by direct means. Some physicists are even considering alternative theories, such as modified Newtonian dynamics, (MOND), to explain galactic rotation curves without invoking dark matter. These alternatives, while controversial, underscore the deep uncertainties that still pervade our cosmic models. Simultaneously, astronomers are expanding their focus beyond our galaxy. Deep field imaging and gravitational lensing techniques allow us to peer into the distant past, capturing the light of galaxies formed just a few 100 million years after the Big Bang. Each observation contributes to a timeline that is continuously evolving, shedding light on how matter clumped together, formed stars, and eventually gave rise to complex structures like planets and, ultimately, life. At the heart of all this research lies a profound human desire to understand where we came from, why we are here, and what lies ahead. The universe, vast and often indifferent, holds within it the story of everything, from the first spark of hydrogen fusion in early stars, to the formation of our solar system, and the eventual emergence of conscious beings able to ponder their origins. As we push further into this final frontier, we must also grapple with philosophical and existential questions. If our understanding of time, space, and matter is incomplete, then so too might be our understanding of life's place within the cosmos. Could there be other forms of intelligence contemplating similar questions on distant worlds? Might our current scientific revolution be only the beginning of a much deeper reckoning with the true nature of reality? For now, each discovery, whether it concerns an ancient star, a strange galactic anomaly, or a new theory of cosmic evolution, adds another piece to the puzzle. And though the full picture remains elusive, the journey of discovery continues to inspire awe and wonder. Stay curious. The universe still has many secrets left to reveal. We will keep closely monitoring technological advancements and new space missions in the coming years. It is anticipated that these missions will offer greater comprehension of the problems facing the universe. The James Webb Space Telescope possesses exceptional capabilities and will continue to push the boundaries of what we know about the universe. We're not only investigating the age of the universe or stars but also attempting to comprehend the complex mechanics of galaxies, dark matter, and the forces that drive the evolution of the universe. Understanding how the universe expands is still an important area of study in astronomy. However, as we accumulate more information, it may indicate that our previous conclusions were constrained, or even erroneous. One important question is whether the physical laws we have come to believe in apply uniformly throughout time and space. Could there be unidentified forces or phenomena influencing how galaxies move or how stars age? As our tools become more advanced, we might find new components of the universe that defy even our most accepted theories. More and more researchers are recognizing that our grasp of dark matter, dark energy, and the fundamental forces may be insufficient. Every new observation, from far-off galaxies to ancient traces of stars, brings new insights but also introduces new uncertainties, pushing the limits of our scientific comprehension. The idea that stars may have existed before the universe, or that the universe may have existed longer than current models indicate, urges a total rethink of our approach to cosmology. This might call for novel physics, new theoretical frameworks, or even radical ways of viewing space and time. These developments also stir deep philosophical considerations regarding existence itself and humanity's place in this vast universe. Assuming such findings, they wouldn't just redefine science, they could revolutionize how we view reality as a whole. The actual age of the universe has not changed, but one thing is evident: we stand at the edge of a transformative period in astronomy. The next few decades might provide answers to questions that have challenged us for thousands of years. Whether we're searching for ancient stars or the unidentified forces of dark matter and energy that continue to fill the universe, secrets are waiting to be uncovered. The road ahead is one of exploration, investigation, and constant re-evaluation of what we think we know. While the answers may still lie beyond our grasp, the thrill of exploration is only beginning. For additional information on these engrossing theories and studies, stay curious and stay connected. You never know what incredible frontiers of knowledge we'll reach next. If you'd like to stay informed about the latest in astronomy and space science, adhere to our channel, hit the like button, and turn on notifications so you don't miss a thing as we continue to explore the mysteries of the universe. The future is full of potential. The James Webb Space Telescope, with its revolutionary imaging technology, is poised to be a pivotal instrument in unraveling cosmic secrets. Already, it has unveiled astonishing new insights into distant galaxies, alien worlds, and other celestial phenomena. But its mission has only just begun. As Webb probes further into space, it could find information that alters our fundamental comprehension of the workings of the universe. One of the most exciting areas of research is the search for essential planets. With new exoplanets identified in the so-called habitable zone, the possibilities of finding life on other planets have never been brighter. Despite the fact that current findings don't offer definitive proof of life beyond Earth, they certainly suggest the possibility of finding even the smallest signs of existing life elsewhere in the universe. This would have sweeping implications for science and philosophy, altering our perceptions of evolution, biology, and the role of humanity in the cosmos. In addition, as we proceed to investigate the enigmatic forces of dark matter and dark energy, our scientific frameworks will face additional scrutiny. These mysterious components, which constitute the majority of the universe's energy and total mass, are largely misunderstood. Solving the puzzles surrounding dark energy and dark matter could unlock profound insights into the very essence of the universe. Alongside this, the study of the behavior and movement of galaxies is yet another important area of focus. For instance, the realization that stars in the outer regions of the Milky Way are moving more slowly than anticipated has led scientists to revisit models of how galaxies function. This could mean that our galaxy, and perhaps others, has far less dark matter than once assumed, raising important questions about gravity and cosmic structure. Such revelations demonstrate the power of new data to compel us to overhaul even our most foundational theories. In the same vein, evidence that galaxies evolve in previously unrecognized ways shows the importance of refining our cosmological models. Could the universe be vastly older than we think? Are there chapters of its history still hidden from view? These are the kinds of puzzles researchers will strive to solve in the years to come, as they synthesize observations from both new and past space exploration efforts. One thing is clear: our current picture of the universe is incomplete. With each new discovery, we become more aware of how much is still unknown. The sense of awe, and the endless search for knowledge, is what fuels the spirit of scientific inquiry and exploration. As we continue our journey into the depths of space, collaboration across scientific disciplines becomes increasingly crucial. Astronomers, physicists, biologists, and engineers are now working side by side, sharing insights and developing tools that were once the stuff of science fiction. This convergence is accelerating our understanding at an unprecedented rate. Quantum computing, artificial intelligence, and machine learning are also becoming essential in decoding the vast amounts of data collected from telescopes and probes. These technologies enable us to identify patterns, simulate cosmic phenomena, and predict celestial behavior that might otherwise remain buried in raw numbers. With their help, we are on the cusp of potentially discovering not only where we come from but also where we might be headed. At the same time, international cooperation in space exploration is reaching new heights. Agencies across the globe, NASA, ESA, JAXA, CNSA, ISRO, and more, are joining forces to pool knowledge and resources. Together, they are planning bold new missions, such as building permanent stations on the Moon, launching manned expeditions to Mars, and sending robotic explorers to icy moons that may harbor subsurface oceans. Yet, with every advancement comes responsibility. As we extend our reach, ethical considerations about the exploration and possible colonization of other worlds must not be overlooked. Questions arise: how do we protect alien ecosystems if they exist? What rights do we assign to new life forms we might discover? And how do we ensure that humanity's expansion into space is guided by curiosity, respect, and a commitment to peace? The future of space exploration isn't just about discovering the universe, it's about rediscovering ourselves. In seeking answers to the great cosmic questions, we inevitably confront the nature of our own existence. What is life? Why are we here? Are we alone? With the universe as our canvas and science as our brush, we are painting a picture of reality more intricate and beautiful than we ever imagined. And while we may never reach all the answers, the pursuit itself binds us together in wonder, inspiring generations to look up and ask, what else is out there? So stay curious. Keep exploring. The cosmos is calling, and we're just getting started.